All right, today we're going to go from the drawing board right into the pump room. We're going to see how a building's most critical life safety system actually comes to life. It's a fascinating journey, really, from a simple blueprint to a certified lifesaver. And it all kicks off with one single, very important question.
Just imagine it for a second. The absolute worst-case scenario. A fire breaks out, maybe 20, 30 stories up. The sprinklers go off, the firefighters show up with their hoses. But what is the one thing that both of those need to actually work? What stands between getting a handle on it and a total disaster?
You got it. It's the fire pump system. This thing is the powerful, beating heart of the building's defenses, designed to shove massive amounts of water exactly where it needs to go, right when it's needed most. But how do you know it's going to work? Well, that's what commissioning is all about.
You know, every single one of these life-saving systems, it doesn't start with pipes and motors. Nope. It starts with numbers. Before anyone even thinks about turning a wrench, engineers have to sit down and do the math, calculating the exact demands of that specific building.
The very first calculation is all about flow rate. The system has to supply all the building sprinklers at once, which in this case is 1,500 gallons a minute, plus it needs to have enough left over for the fire department, another 500 gallons per minute for their hoses. So you add it all up, and you get our target, a whopping 2,000 GPM, or gallons per minute. Okay, next up is pressure. The pump has to be strong enough to push all that water straight up, fighting gravity the whole way. It's also got to overcome all the friction inside hundreds of feet of pipe and still have a good safety margin at the end. For this particular system, that magic number is a minimum of 80 psi, or pounds per square inch.
So how much muscle does it actually take to move 2,000 gallons of water every minute at 80 psi? Well, that's where horsepower comes in. It's calculated using a specific formula that basically connects the dots between flow, pressure, and the pump's own efficiency.
So you plug in our numbers, you run the math, and the calculator spits out that we need about 132 horsepower. Now, you can't just go out and buy a 132 horsepower pump. They come in standard commercial sizes. So the designers just select the next size up, a nice robust 150 horsepower motor. And just like that, the blueprint is complete.
With all the components installed, we move to our really critical phase, the pre-power checklist. This is a super meticulous, hands-on inspection to catch any physical problems before a single volt of electricity is applied to the system. Skipping any of these steps could be absolutely catastrophic. We're talking about questions like, is the pump perfectly aligned with the motor? Are all the electrical terminals torqued down tight? Is the grounding secure? Technicians will literally check the serial number on the pump's nameplate against the approved drawings. This isn't just paperwork. It's about preventing a violent failure on the very first startup.
The physical checks are all done. Everything looks good. And now, for the moment of truth. This is the system's first breath, and it's a very carefully controlled sequence to bring this powerful machine online for the very first time. Yeah, they don't just flip a big switch and hope for the best. First, a small Jockey pump is started. Its only job is to get the system up to pressure so they can check for leaks. Then, the main pump is started manually, just for a second, to confirm it's spinning in the right direction and running smoothly. And finally, they simulate a fire by opening a valve, dropping the pressure. They watch and wait, making sure that main pump roars to life automatically, just like it's designed to do.
So the pump can start, that's great. But can it actually perform under pressure? Well, welcome to the system's Olympic trial. This is where the pump has to prove it can deliver on all those promises that were made back on the blueprints.
The test is run at 3 critical points. First is the churn test, with zero flow, which checks the absolute maximum pressure the pump can generate. Then comes the 100% flow test to verify its performance right at its rating. And finally, they push it to its absolute limit with the 150% overload test, just to make sure it can handle extreme demand without failing.
And the ultimate pass-fail for this whole thing? It's actually really simple. Every fire pump ships with a certified performance curve right from the manufacturer. It's a graph that shows exactly how much pressure it should produce at any given flow. The results from the real-world test must match this curve. There is zero room for error here.
But it's not just about pressure. The technicians are also monitoring the motor's electrical draw to make sure it isn't overworking. They're checking for any overheating, feeling for excessive vibration. They even watch the suction gauge to make sure the pump is getting a steady, uninterrupted supply of water. It has to be powerful, sure, but it also has to be stable.
The pump has passed its performance test with flying colors, so now we're in the final phase. It's time to test its communication with the building's other safety systems and get all the final documentation in order.
A fire pump doesn't work in a vacuum, right? A signal has to be sent to the building's main fire alarm panel the second it turns on. And just as important, it has to send a trouble signal if it fails. For systems with diesel backups, they test the low fuel alarms. This whole process ensures the building operators know the status of their most important life safety system at all times.
So let's just quickly recap the core components that have now been fully tested and certified. Each one of these pieces plays a critical role in making the whole system reliable.
At the very heart of it all is the main electric pump. That's the 150 horsepower workhorse we calculated way back at the beginning.
But of course, power can fail in a fire, so an equally powerful diesel-driven pump stands ready as a critical backup.
And managing them all? Those are the brains of the operation. A set of dedicated controllers that make sure the response is seamless and automatic, right when disaster strikes.
And tying it all together is all the essential hardware, the huge 8-inch pipes to carry that massive flow, the valves and gauges that control and monitor the pressure, and of course, the fuel tank that ensures the diesel backup is always ready to run. And that's it. The journey is complete. Through meticulous design, very careful inspection, and some seriously rigorous testing, a collection of pipes and motors has been transformed from just a plan on paper into a certified, reliable lifesaver silently standing guard.
This whole complex process is what guarantees the fire pump will work when you need it most. It kind of makes you wonder, doesn't it? What other invisible guardians are built into the world all around us, tested and certified just to keep us safe? Thanks for diving into this with us.